Hello, everyone. In today's lesson, we're going to talk about one-to-one functions. And so we're going to discuss just kind of a recap of what a function is. And then there are a special group of functions called one-to-one functions. So here's where we're going to start off. It says, a function must be one-to-one in order to have an inverse. And so what does one-to-one mean? So, this is why one-to-one is important, because we've got to have it in order to be an inverse. And if we think back to mapping and the definition of a function, it will help us understand what one-to-one means. So remember when we had a relation, we said we have our x inputs right here and our y outputs right here. And you put in a 3, 5, and 8, and they map over to these numbers. So you put a 3 into the function, out pops a 6. Put in a 5, out pops an 8. Put in an 8, out pops an 11. So yes, this is a function because there's no x value that spits out two different y values. Let's look at another one down here. This one goes from -5 to -7, 0 to -2, and 9 to 7. Once again, it's a function. For every x input, I have exactly one y output. Let's look at the one over here on the right. And I needed one more example, so I kind of squeezed him in right there. If you put in a 1, out goes an 8. If you put in a 2, out comes a 2. Put in a 3, out goes an 8. Put in a 4, out goes a 9. Once again, for every x input, I have one and only one y output. So that's how we looked at this mapping thing with deciding if a relationship was a function or not. Now we're going to look and say, are these functions a special kind called one-to-one functions? And so one-to-one functions work like this. Going back to our definition of a function, for every input, there's only one output. A one-to-one function works backwards that way. For every output, there's only one input that maps to it. So for instance, 6 right here does not map to anything else backwards but 3, all right? 8 only maps back to 5, and 11 only maps back to 8. So this is a one-to-one function. And remember, that's important to know because that means that this does have an inverse here, or it can. Now, if we look at this one down in the bottom right, what's going on with this? Well, we've got 1 maps to 8, and 8 maps back to 1. 3 maps to 8, and 8 maps back to 3. So in this case, notice, I don't have for every y value only one x value mapping to it. 8 would map back to 3, and it also maps back to 1. And so this function is not one-to-one. And so we have to do something if we're going to try to generate an inverse for it. Now this one is one-to-one. For every y value, it maps back to only one x value. Now, if I give you a little bit more of a real example here that you're used to seeing, it will help you out. So let's look at x squared. So suppose we have y equals x squared, and let's make an xy chart for it. So when I put in, let's go with -3, -2, -1, 0, 1, 2, and 3. And let's look at our y values. So we're going to be squaring x to get our y value. So we get 9, 4, 1, 0, 1, 4, and 9 again. And let's create a mapping for it. So our x values can be -3, -2, -1, 0, 1, 2, and 3. Our y values can be 0, 1, 4, and 9. And so when we do a mapping here, we're going to say, okay, -3, it maps to 9. -2 maps to 4. -1 maps to 1. 0 goes to 0. And then because my lines are all crisscrossing here, it gets kind of confusing. So I'm going to switch colors when we get to the positives here. 1 maps to 1. 2 maps to 4. And 3 maps to 9. So this is a function. For every x value here, I have only one y value. But this is not a one-to-one function. And the reason why is, notice that 9 would go back to 3 or -3, right? And that's why we have just the old y equals plus or minus square root of x is not a function. Because if I put 9 into this, I could get the positive value of 3 when 9 goes in for x, or I could get the negative value of 3, and this is not a function. So this one-to-one thing is leading us up to what we call inverse of functions. And in order for it to have an inverse, it has to be one-to-one. So this does not have an inverse. If you're still like wondering, not quite sure what we're going with this, let's look at it graphically. So my question is, what does one-to-one look like graphically? So we're going to switch over to Desmos here. And I'm going to put in the first function I had listed there, which is x plus 3. So the f of x is equal to x plus 3. And notice we've got that linear parent function there shifted up 3 units. And is it one-to-one? Well, it is. For every x value we put in, we get one y value, making it a function, and then it works backwards that way too. For every y value, it only maps back to one x value. So remember our vertical line test. So if we have just say x equals a, that's not gonna let me add a slider there. Where's my slider? Let's try this. Y equals a. I think I did this last time. Let me pause the video and I'll see if I can get a slider added in there for us. Okay, I think I found a way to trick it. So I'm going to say y equals ax. It wants a to be a slider. And now I'm going to remove the x and replace the y with an x there. And notice over here it graphed a vertical line. So I've got x equals a is a slider, and now I can, and it's for the sole purpose of doing the vertical line test to make sure it's a function. So yes, this is a function. Now to test graphically if a function is one-to-one, we do the horizontal line test. So I'm just going to put in a horizontal line. Let's do this time y equals b. No, it's not, let's see here, b, there we go. It's funny, you got to trick it. And let's remove that x there. And now I've got a horizontal line test. Recall that the vertical line test said that if we pass that vertical line over it and it intersects the graph anywhere more than one time, it's not a function. So this one passes that test. The horizontal line test says the same thing. If we put a horizontal line on it and move it anywhere with the function, it should not intersect it twice, which in this case, it does not. Now I'm going to turn off this function and let's put in our other equation there, x squared. So I'm going to add that. Let's see here. F of x is equal to x squared. So there's our function, and notice that the vertical line test works for it. Doesn't intersect it anywhere more than once. But if we do a horizontal line test to it, notice right here, I'm intersecting it in 2 points, right here and right here. That tells me that the y value, 1.4 right here, maps back to 1.183 and negative 1.183. And so this is an issue here. This means since it's not one-to-one, it does not have an inverse. And we will have to modify this so we can talk about the inverse to x squared, but it will be, we'll restrict the domain is what we call it. That'll be in the next video when we talk about inverses to functions. What I want you to know right now is what does one-to-one mean? Let's look at one more function here. So I'm going to add another function and let's do e to the x. So you may or may not have seen e to the x before. I want to kind of get you used to seeing e to the x. All it is, and it's here, e. If you hit the letter e there, it knows you're talking about the number e. We'll have a whole lesson where we talk about what does e mean. The value of e itself, it's just kind of like how pi represents 3.14. E right here represents 2.7. Let's see here. Let's just do the, let's get rid of these functions and give you a more exact value here. If we say the f of 1, exactly there, it's equal to 2.7182, blah, blah, blah. It's kind of like pi, it's irrational. It goes on forever. So for right now, all I want you to know is it's a number. Okay, and we're raising it to the x power. This is what the graph looks like. I'm going to change the color because we already got a green line on there. So there it is in red. And notice it passes the vertical line test. And question is, does it pass the horizontal line test? So if we move this horizontal line up and down, does it pass that? And so some students may look at this and say, no, it doesn't, because look, this is like a horizontal line right here. Although it looks horizontal, it's not. It's actually getting closer and closer to the x-axis there as you go towards negative infinity, but it never does quite reach the x-axis. So as I slide that down, it never does intersect it in more than one spot. So is e to the x 1 to 1? It is, okay? So that's how we can test it graphically. We can test it using maps. A lot of times we just use the graph, or if it's a function we're familiar with, we can give examples like x squared. Like if I say 2 squared, I get 4. If I say negative 2 squared, I get 4. That tells me I'm getting two different outputs for, one output for two different inputs there. And so it wouldn't map back to one unique input. So hopefully that made sense as we went through it. If you have any questions, make sure you let me know. And thanks for watching.